Today we're going to look at 4 trigonometric identities, the most simple ones to start with. Now, you probably remember so, ka, tawa. Applying this principle to this triangle, we can see that the sine of theta is equal to a over 1. Cosine of theta is equal to b over 1. The tan of theta is equal to a over b. Now, since this is a over 1, it's equal to a. Since this is b over 1, it's equal to b. So tan of theta is equal to sine of theta over cos theta. Sine theta over cos theta. This is our first important trigonometric identity. Now, let's look at the next one. Here we can use Pythagoras' theorem. We know that a squared plus b squared is equal to the hypotenuse squared, which is 1, which is equal to 1. We know from the previous identity that sine theta was equal to a and cos theta was equal to b. So a squared is equal to sine theta squared and b squared is equal to cos theta squared. It's conventional to write these expressions like so. Sine squared theta plus cos squared theta is equal to 1. And this is our second important trigonometric identity. We write it like this to avoid these extra brackets. These brackets can be cumbersome and cause us annoyance, so we write it like this. In the same way, if we want to write sine cubed of theta, then we would write it like this. Avoiding those brackets makes your mathematics more beautiful and more elegant. The next 2 trigonometric identities come as a pair. We can say that we use both of the acute angles, and the hypotenuse in this case we can just say is length c. Now, we know in a triangle the angles add up to 180 degrees, or that is pi radians, and this right angle is pi over 2, and so this angle here is pi over 2 minus theta. So, here comes the lovely part. We know that the sine of theta is equal to the opposite over the hypotenuse, and the cosine of theta is equal to the adjacent over the hypotenuse. Now, if we rotate all of this by 90 degrees, then we can say the sine of this angle, sine of pi over 2 minus theta, is equal to b over c, and the cosine of pi over 2 minus theta is equal to a over c. A over c. So now look here. A over c, a over c, and b over c, b over c. So the sine of pi over 2 minus theta is equal to b over c, which is equal to cos theta. And similarly, the cos of pi over 2 minus theta is equal to A over C, which is equal to sine theta. And these are two more trigonometric identities. How lovely is that? Now, I've flipped our triangle back to the right way up, and I've put all of our rules that we've learned here today in this corner. And I want you to try this challenge. Show that for every acute angle theta, the tan of pi over 2 minus theta is equal to the reciprocal of tan theta. Pause the video and then we'll run through it. Okay, now you can see that the tan of theta, this angle, is A over B, opposite over adjacent, and so you can see that 1 over tan theta is the reciprocal of A and B. So A and B, tan theta, 1 over tan theta is B over A. Now, if you imagine flipping this triangle over again, you can see that the tan of pi over 2 minus theta is equal to opposite B over the adjacent A. So, therefore, the tan of pi over 2 minus theta is equal to 1 over tan theta. B over A, B over A, this is 1 over tan theta, and that is your proof. Very nice. If you've enjoyed the video, click the subscribe, like, comment and share. Bye.